Hey everyone, welcome back to Prince of Patterns. If you are new here, my name is Prince and I hold a bachelor's in statistics, a master's in data science, and years of experience in AI, machine learning, and published research. Today, we're diving into why AI isn't always the answer and when alternative approaches are preferred. I know AI is powerful and amazing, but sometimes simpler methods work better and make more sense. Let's get right into it. I'm starting off with cost and complexity. Implementing AI solutions is a huge investment in costs, in talent, in infrastructure, and in time. For small-scale or straightforward problems, sometimes traditional statistical methods or simpler algorithms are cost-effective and make more sense. For example, imagine you want to build a tree house and you go get a large-scale construction company to help with that, with the cranes and like 50 engineers, when you can just get wood, a couple of nails, and friends to help you out with that. Let me get a better example. Let's say you want to do arithmetic, you want to add and subtract things for your business. You don't need to go and buy the latest NVIDIA product, GPU, or go and get a supercomputer for that. You just need a normal Casio calculator. This is not an ad. Or for example, a small scale business needs inventory, like a really small scale university business, something that a spreadsheet can solve. You go and pay for Salesforce subscription. Yeah. If a small business just wants to track inventory, a simple spreadsheet can work better instead of trying to train AI and trying to build your own Salesforce model. Data quality and availability. I want you to think of AI as a chef trying to make quality meals. Let's call the meals the results. The ingredients are the data that the AI uses to train on. You have a checklist of what you want to use to make a soup, and the ingredients are not complete, and they are old, they are stale. Obviously, the food wouldn't taste as good as someone else with the complete fresh ingredients. That's how you should look at it. AI thrives on large data, so it predicts better with bigger data. AI works. Similarly, if data is messy or incomplete, the AI will definitely make mistakes. AI cannot do better than the data is trained on. Zay, please can you put that in like a quotation mark and like Prince 2024? Yes, thank you. That would be nice. For example, if you are training your AI to predict what toys kids will like, and you're only training the AI on a particular neighborhood, obviously it wouldn't perform well with kids from a different neighborhood. Let's say they are a different socioeconomic class, maybe it's different shows they watch. A kid in Russia may not want the same toy as a kid in New York. I want to quickly talk about something called survivorship bias. Pretty cool name. Survivorship bias is when the data is incomplete, but the model doesn't know that. So it's only trained on a part of the data and it leaves off the other part that it never saw, making the data or the results bias. So there's a quick story from World War II. I'm not sure about the validity of this story, but it said that the Allied groups, I'm guessing, they had like a lot of jets, fighter planes coming back from the battle, and they had bullet holes in them. So they wanted to add armor to some parts of the plane so that they'll be well protected. So there was a graph of the plane, the World War II fighter jets, and had different holes, like different points to show the bullet holes, the data on the bullet holes on different flights that came back. And everyone wanted to put armor on the ones that had more dots. But a wise man came and was like, no, the places on the planes that don't have dots are the places that we should put more armor on. Why? Because the planes that were hit, they came back safely to the base. But the places that there are no dots, which simply means when a bullet hits there, whoever was there died. So we should add more armor there. That is an example of survivorship bias. Why? Because all the other smart scientists or whatever, they wanted to put armor on the parts that are actually safer. But in reality, the lack of data showed what really needed to be done in that scenario. Let's talk about casinos. By the way, I love casinos because I'm a statistician, so why not? Please remove that part. In a casino or all these betting sites, they are always showing you people that win. So when you enter into a casino, you hear loud sounds. And every time someone wins, the machine makes a very loud sound, shines lights. So everyone is looking, telling me congrats, yo bro, you owe me money, all that. But when you lose, it doesn't make no sound. It's really quiet. So when you enter the casino, you naturally feel like there's a higher chance or probability of you making money and cleaning them out that evening, because using the survivorship bias to their advantage is the idea of the data not being incomplete and being trained on something that makes it biased in the results. I hope you understand that now. Interpretability. Many models, especially deep neural networks, are black box. Black box meaning it's not really explaining why it made a decision, it just tells you the results. There are many situations in which we would like to know why does this result tell this. Let's say in healthcare, for example, if a model says take this drug, take an aspirin, take that, and it doesn't say why, obviously we can't take the recommendations of the model, because this is a human life we're talking about. Simple models like decision trees can be used instead. I will later make an in-depth video on decision trees, but basically decision trees just answer the questions this or that. Let's say there's a magic box that tells you the answer to a riddle but doesn't explain how it connects. That would be really annoying, right? That's exactly how AI can be in certain situations. I'm going to quickly talk about a concept called bias complexity trade-off. I'm using all these like major phrases to explain, so that when you're done watching this video and you mention survivorship bias or bias complexity trade-off, everyone is like, yo, this dude is on fire. They don't know it's like a 5 minutes YouTube video they watched. A simple example of bias complexity trade-off. Let us imagine that Google Map was like a treasure map. X marks the spot. X is where your office is. X is where the treasure is. And X is where your home is. And there is really no details on like street turnings. The road is not part of the map. It's just trail. You don't know if that trail is for bicycle, is for walking. You don't really know. It's just a very simple plain map, like a treasure map. No one is going to use that Google Map. But let's imagine Google Map and it has every single detail for no reason. It has the detail on human beings walking and everything is distracting the map. It has the details on the trash can on your street. It has unit details of every bird passing at every time. The map will be very messy and you wouldn't like that. You want something that is optimal, that is not too complex, not too simple. That's the idea of bias complexity trade-off. Please comment the things that you want me to make in-depth videos on, because each of these concepts is a lot to cover inside, but that is just a basic example of bias complexity trade-off here. On the other hand, a simpler model, they may not be too detailed, but they have just the right information that you need. Here I'm going to talk about decision tree. It acts like a flow chart for computer science students. But if you don't understand what that means, it just simply means a tree. Imagine the branches of a tree. Why do you do this? Why do you do that? Okay, why do you go to work in the morning? Do you like your job or you're looking for money? You're looking for money. That is one way. Okay, why did you pick that job? Is it close by or you have an office crush you want to meet every day? Okay, it's close by. You don't want a long commute. Okay, why are you driving? Why didn't you take the train? Because driving is faster. It's each step. There's a conditional statement, why this or this. That's a decision tree. I will go into it in future videos. Ethical considerations. I said earlier that an AI model cannot do better than the data is trained on. So let's imagine an evil person in a fantasy world wants to make an AI model and they train it on evil data. AI is not bad. It's just that it can't do better than the data is trained on. All your fears of AI taking over, it just simply means that someone trained the model on how to take over the world, which just shows how dangerous AI is. I wrote a paper on ethical implications of AI in financial decision making for the nerds that like the boring stuff. It's not really that boring. I'm going to link it in the bio or the description of this video. The outcomes of the AI, because it's dependent on the data it's trained on, it will be unfair if it's trained on unfair data. This is one of the many risks associated with AI. Imagine there's a robot that wants to learn how to play football, an AI robot, like in the ad Galaxy 11, if anyone remembers it, 2013, I think. And then that model, instead of you to train it on Lionel Messi or Ronaldo or people that play well, you go and train the model on Vinicius Jr. or on Sergio Ramos. Obviously, the model is going to dive, cry, and injure people and be very rough and commit a lot of fouls, simply because the model was trained on players that play rough. The model is not bad, so don't hate the player, hate the game. Hate the game, not the player. Yeah, I got it. Problem solution fits. Not every problem is complex enough to require AI. Sometimes a simple rule-based algorithm or a simple solution is best. When you give birth to a kid, the doctors don't need a trained AI model to know if he's a boy or a girl. They will just look, see what they want to see, slap the ass, the baby cries, and give you your child. That's it. They don't need to train a model that will look at a baby and tell you if he's a boy or a girl when he's already born. That seems redundant and waste of resource. If you want to get home from like your neighborhood, you don't need a trained AI model to tell you how to get home. You just know it's common sense. Go straight, turn left. There are simpler models that can tell you that. You don't need an AI model for that. I'm ending this with a quote by me, of course. The coolest solution is not always the optimal solution. I want you to print this out, send this to your group chat, tag me, quote me, please. Don't play, guys. Send it to your boss that is always talking about AI this, AI that, and ask a question. Is the data available? Is the data clean? Is the ethical frameworks, is it ethically right? Is it interpretable? And this video actually make you sound cool. You ask about the survivorship bias, you ask about the bias complexity trade-off, and yeah, you write about it in the comment section. I would like to know how the results came out after you explained it that way and what you think about it. That's it for the video. Thank you for listening this far. Please, I would like you to subscribe, like, comment the parts you want me to explain deeper on in the future, and I'll see you next week. Bye.